Hi Gr11s, today we're going to look at the sum of the geometric sequence. Let's just unwrap the formula. So this formula will be given to you. So Sn of course is the sum of a certain number of terms. N, A is the first term, like always. So the first term, and N of course is the number of terms. So the number of terms. R is equal to, and there's another R, that's the ratio. Right, term 2 divided by term 1 should be equal to term 3 divided by term 2. And yeah, so that's all you need. So in this case, you need the ratio, the number of terms in the first term, and then you can find the sum of it. All right. I'll be running through a couple of examples, just talk it through. So yeah, you're welcome to follow. Okay, so let's look at example 24 there. So you find the sum of the first 12 terms of the series 2 over 3, 2, 6, and so on. So they're not going to tell you it's a geometric sequence or a quadratic sequence. Quadratic you can only add the terms, right? There is a formula, but we don't use the formula. You will only be being asked to find the sum of an arithmetic sequence and a geometric sequence. Okay, so you need to know what type of sequence it is. So first of all, you need to spot that that's a geometric sequence. And how do I do that? Well, there's not a common first difference, but every single term there is being multiplied by 3, right? In other words, if I would want to go term 2 divided by term 1, in other words, 2 divided by 2 over 3, that must be then the same as term 3 divided by term 2, 6 divided by 2. 6 divided by 2 is 3. 2 divided by 2 over 3 is equal to 6 over 2, which is also equal to 3. Right, so it's a geometric sequence. Why? Because it's got a common ratio. Okay, so what I would encourage you to do is you write down what you need. So you've got A is equal to 2/3. You've got the common ratio. The common ratio is 3. Do we know how many terms you want to add? Absolutely, it's the sum of the first 12 terms. And we want to then know what is the sum of the first 12 terms. So therefore, the formula Sn is equal to A times by r to the n minus 1 over r minus 1. I would encourage you to write down that formula just as is, and then you substitute just in the beginning. So it's the sum of the first 12 terms. A is equal to 2 over 3. And then r is equal to 3, so that must be in brackets, to the power of n, so to the power of 12 minus 1 over 3 minus 1. Okay, so that's not too bad. Hey, you just substitute a into a, r into r, and then n into n. What is very important here is to use your calculator correctly. So first thing you're going to do is you're going to press the fraction button, and then is a fraction on the numerator, that is 2 over 3. Goodness. And then is the bracket, and it is r to the n, so it's another bracket, 3 to the power of 12, and then fourth button, minus 1. Okay, so just make sure it's all right. Don't subtract 1 from the exponent. And then it is over 3 minus 1, right? So the ratio minus 1. And then that answer is that. And then you just press the S2D button, right? And then you're going to get that, and you round off to 2 decimal places. Okay, so that's not too bad, eh? Right, so now let's look at example 25. As was the case in arithmetic sequences, I can also ask you to find a sum where you don't at first know how many terms there are, where I give you the value of the last term. Remember, if I have a value of a term, I can find out which term it is, right, by using the general term. So our first objective is we need to know how many terms there are, right? And then of course we need to find Tn. Okay, so let's go through it. But before we do that, A is equal to a quarter, 0.25, right? So that's a quarter. And then the common ratio, what happens here? 0.5, so term 2 divided by term 1, and term 3 divided by term 2, that is going to be equal to 2. Hey, every single term doubles. So that's going to equal to 2. 1 divided by half is 2, 0.5 divided by 0.25 is 2. Right. And then, of course, once we know what n is, we can find the how many terms there are. All right. And then the sum. So let's go for it. The general term is going to be a r n minus 1. So that tn is equal to a, which is equal to a quarter, 0.25. And then r is equal to 2, and then to the power of n minus 1. Okay, and then we know what the value of the term is. It's 256. So quarter times by 2 to the power of n minus 1. So now what we're going to do is we're going to divide a quarter on both sides, right? Please do not multiply. Don't multiply the quarter to the 2. Please, I mean, that will just be strange to the highest degree. Do not. I'll watch you. So don't multiply the quarter to the 2. So you're going to multiply 4 on both sides. That's the same as dividing by a quarter on both sides, right? So let's go for it. So we've got, so multiply by 4 on both sides. So it's 256 is equal to, if you multiply a quarter by 4, it's 1. That's why we multiply by 4, is equal to 2 to the power of n minus 1. 256 divided, times by 4 is equal to 1024. So 1024 is equal to 2 to the power of n minus 1. Okay, so you can either use logs. You guys know how to use logs by now, or you can just make the bases the same. I'm just going to do both because sometimes you can't make the bases the same, then you need to use logs. Okay, so this one is with equal bases. It's all about the base. Okay, so 1024 is 2 to the power of 10 is equal to 2 to the power of n minus 1. So the bases are the same, therefore 10 is equal to 10 is equal to n minus 1, therefore n is equal to 11. All right, in other words, 256 is the 11th term. That's what that means. All right, if we wanted to do it by using logs, log. So you would say, well, remember how it goes? So it's base exponent is equal to the number, right? And then if you convert that into log form, it is log base number is equal to exponent, right? Good. So it's log, the base is equal to 2, the number is equal to 1024 is equal to n minus 1. Log base 2 1024 is equal to 10, so 10 is equal to n minus 1, so therefore n is equal to 11. Right, doesn't matter which way you do that. Okay, so the first part is we just need to find out how many terms there are. In other words, you find which term is equal to that value of the last one. All right, and now we can just go through our normal routine. So in other words, Sn, the sum of 11 terms, is going to equal to, so the formula is Sn is equal to a r to the n minus 1 over r minus 1. So the sum of the first 11 terms is equal to a, which is equal to a quarter, r, which is equal to 2. So it's 2 to the power of 11, right? The sum of the first 11 terms. This 11 there looks a bit dodgy. Okay, and then minus 1 over 2 minus 1. You follow? You substitute 2 into r, you substitute 11 into n, and yeah. And again, please don't be strange. Don't multiply the quarter to that. I mean, just don't, okay? You can't do that. So what do we have here? So we've got the sum of the first 11 terms is a quarter, and 2 to the 11 minus 1 is, 2 to the 11 is equal to 2048, minus 1 is 2047, right? And then 2 minus 1 is 1. So it's a quarter times by 2047, which is then 511.75. Okay, so let's look at another example. So how many terms of the geometric sequence minus 1 to minus 48 will add up to 349,525? Okay, so what happens if those signs change again? Okay, so that would mean the ratio is negative, right? Because negative times negative is a positive, times negative is a negative, times a negative is a positive, times negative is a negative. So yeah. So that means the ratio is negative. So let's quickly go, what do we know so far? So we know that a is equal to minus 1. What's the ratio going to be? What's term 2 divided by term 1? Minus 2, right? 2 times divided by minus 1 is minus 2. Minus 4 divided by 2 is minus 2. 8 divided by minus 4 is minus 2. And then, do we know how many terms there are? No. But we know the sum now. We don't know, it's the sum of a certain number of terms is equal to 349,525. You get so excited. So you write down the equation, Sn is equal to a r to the n minus 1 over r minus 1. Can I also just tell you again, okay, so I taught you it's a geometric sequence, but please don't write down the sum of an arithmetic sequence now. I mean, that just makes no sense. I mean, goodness, that's irrational as the root of 2. So let's go for it. So we know what the sum is. The sum is equal to z. So 349,525 is then equal to a, which is minus 1, and I would put that in brackets. R, which is minus 2, definitely put that in brackets. N, we don't know what n is, and then minus 1, and R, which is minus 2, minus 1. So therefore, what do we have? So we've got this 349,000, baby, and then we've got the minus 1, so it's minus 1, minus 2 to the power of n minus 1, and then minus 2 minus 1 is minus 3. You don't need to do all these steps. I'm just doing it for now. So 349,525 times by negative 3 is then equal to 1,048,575. Oh goodness, that's a bit high. And that then is equal to minus 1 times by minus 2 to the power of n minus 1. Okay, so what's our next step? We want to get rid of this minus 1 here. So we're going to, that's a negative. If you multiply by minus 3, that will be a negative. So the first thing is we want to get rid of this minus 1 times by this bracket. So you're going to divide minus 1 on both sides, right? So we've got minus 1,048,575 divided by minus 1 is equal to minus 2. We can still have it in brackets just for now. Okay, and then that answer, of course, is going to be 1,048,575 minus 2 to the power of n minus 1. Okay, hope you're following. And then what we do, we need to add 1 to that. So in other words, it's going to be 1,048,576 is equal to minus 2 to the power of n. Right, so now you've got one of those choices again. You need to find a variable that's an exponent. You're either going to make the basis the same. And I know you all know that 2 to the power of 20 is equal to 1,048,576. That's very cool, eh? So, in other words, minus 2 to the power of 20, if you want to make those bases the same. Remember, negative to an even number exponent will be a positive answer, so that makes sense. So therefore, n is going to equal to 20. If you wanted to go the log route, okay, so you didn't know that minus 2 to the power of 20 is equal to that, you can then write it in log form. The only thing, your calculator, we don't want a negative base. We'll explain that a bit later. But so what you've got is you've got log. Remember, it's the base, the number is equal to the exponent. So what you do is you just make the base positive just for now. The number is that 1,048,576, and that is equal to the exponent, which is n. And if you type that in your calculator, you get n is equal to 20. Right, that will work, and of course it will work. Just double check if the negative coefficient raised to an even exponent is going to be positive. But anyway, we'll elaborate on that a bit later. So, but there's n is equal to 20 either way. Example 26 in your textbook is very similar to that. So let's go through it, but it's now just in sigma form. It's the same story. Remember, sigma means, no, not general terms, sum. Focus. Sigma means sum. It's the sum of all those terms, right? Okay, so let's go for it. So if you're not sure what to do with sigma, what do? Yes, you work out the first three terms. So the first three terms, that's what you're going to do. So let's go for it. That's his first three terms. Okay, so what's term 1 going to be? Term 1, and then we're going to work out term 2, and then we're going to work out term 3, and then blah, 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 blah. Okay, so term 1, you've got -3 times by -2, I minus 1. Let me just write that. And then you've got all of those the whole time. -3 times by -2, I minus 1. Again, you don't need to do this. It's just for illustrative purposes. So I minus 1, and there we go. So in other words, what you're going to do is, remember what you do, you substitute the bottom count to it. You see it's I is equal to 0. So you substitute the bottom counter into the variable of I. So in other words, it is -3 minus 2 to the power of 0, and then minus 1. And then remember, you increase that by 1. Okay, so it goes up into the next integer, So it's -3 minus 2, and then it will be 1 minus 1. Yes, well done, I heard you there. And then it is -3 minus 2, and then it is plus 1, so it's 2 minus 1. All right, plus dot, dot, dot. Okay, so what's that equal to? So it's going to be -3, so it's minus 2 to the power of minus 1, plus -3, so it's going to be minus 2 to the power of 0, plus, and then -3 minus times by minus 2 to the power of 1. So therefore, what is that going to be? That simply means it's -3 over -2, right, to the power of 1. But you can just use your calculator for now. And that means -2 to the power of 0 is 1, so that answer is just going to be -3. And that answer is going to be -3 times by -2 is equal to +6. And so on. Alright, so just simplify this first one. So it's 3 over 2 plus -3 plus by 6, and so it goes on. Right, we also know, so remember I taught you that this is like the general term there of what's been formed, and you can actually see that, so it's AR to the n minus 1, the ratio is -2, that kind of makes sense. Alright, so just looking at those terms. So what do we know here? We've got A, which is equal to 3 over 2, we've got the ratio, which is equal to -2. What else do we know? We need to just calculate the sum. How many terms are there? Whoops. So how do we know how many terms there are again? So the number of terms is the top counter minus the bottom counter plus 1. So in other words, the top counter is equal to 19 minus the bottom counter, which is, that's 0. And remember what we do then? We plus 1 to it. Okay? Just look at the previous video on sigma. It's about halfway through, if you're not sure. And then that is equal to 20. 19 minus 0 plus 1 is 20. So there are 20 terms. Right, and then we just use the appropriate formula. It's a geometric sequence. We're going to use Sn is equal to A r to the n minus 1 over r minus 1. Right, let's go for it. So it's the sum of the first 20 terms, A, which is equal to 3 over 2, and then we've got r, which is equal to, so it's -2 to the power of 20, and minus 1 over -2 minus 1. So the sum of the first 20 terms, again, you're going to develop diarrhea if you're going to multiply those two in. Please don't. I mean, this is to the power of 20. Just don't do that. That's just weird. Right. So so that's what we've got. So what we can do is you can just type that all into your calculator. I've done an example of that. You just move it all into there, and you're going to get 524,287.5. Alright, and so just round off to one decimal place. Alright, here's the last example I'm going to work through. So what we've got is we've got a sigma, and then of course that will be the general term, that's Tn, and then that part there, the 24 and a fifth, is equal to the sum of the general term of that. Okay, so let's go through it. So what do you do if you see a sigma? Sigma means sum, sigma means sum, so it's a sum, right? So let's work out the first three terms. So it's the first three terms. So term 1 plus term 2 plus term 3 plus, and what we have the answer this time. Okay, so term 2 is a 15th times by 3 to the power of k minus 1. Let's just for now, just keep on writing that throughout. I'm going to be a bit lazy, so let's do that. Okay, so what we're going to do is the counter starts at 2. In other words, it's the same story, so it's a 15th, 3 to the power of, but then it is 2 minus 1. And then it is a 15th, 3, and then 1 up from 2. 2 plus 1 is, yes, I know you can do that, 3 minus 1 plus a 15th, so that's a 15th, it's 3 to the power of 4 minus 1. Yes. And then, so what does that mean? Again, do not multiply those two. Do not. So we've got a 15th times by 3, so that's equal to 3 over 15, right? Because it's 3 to the power of 1. And then we've got 3 square, which is 9, so that's 9 over 15, and then we've got 3 to the power of 3 there is 27, so it's 27 divided by 15, and Okay, so what do we know? We know that the first term is equal to 3 over 15. We know what the ratio is. The ratio is 3, right? You multiply every single term by 3. We just go term 2 divided by term 1, okay, so on. And what we've got is how many terms are there? Do we know how many terms there are in this case? Well, how do we normally work out how many terms there are? Now this is just where you need to focus now. It's the top counter. The top counter is m. So it's m minus the bottom counter. What's the bottom counter in this case? 2. And then we're going to go plus 1. Okay. So in other words, how many terms are there? If you write it in terms of m, it's going to be m minus 1. Alright. Then we're just going to use the formula. We've got the sum now. We've got the sum of a certain number of terms is then equal to 24 and a fifth. Alright, so let's hit it. So Sn is equal to a r to the n minus 1 r minus 1. So therefore, it is the sum. We know what the sum is. Sum is 24 and a fifth. There we go. So 24 and a fifth. I don't like mixed numbers like that, mixed fractions like that. So I would go 24 times by 5 is equal to 120, plus by 1 is 121 over 5. You know, those are the same, that's the same thing, eh? Is equal to a is equal to 3/15, okay, multiplied by the ratio, which is equal to 3 to the power of n minus 1 over the ratio, which is 3 minus 1. Okay, and now it's just a bit of algebraic manipulation. So you've got 121 fifths, you've got 3/15ths, 3 to the power of n minus 1 over 2. Multiply the 2 on both sides, so you get 2/2 over 5 is equal to 3 over 15th, 3 to the power of n minus 1. You don't need to show all these steps, I'm just doing it for now. Okay, how do you get rid of the divide by 3 over 15? You multiply by 15 over 3 on both sides. So you multiply by 15 over 3 there. So you're going to get 2/2 over 5 is equal to, multiply 15 over 3 by 3 over 15, you get 1. That's why you do it, of course. So 3 to the power of n minus 1. Okay, and then what is 15 over 3 times by that? So it's not too bad, I think. 5 goes to himself once, and then 3 times. 3 divided by 3 is 1. So that answer is actually just 242. If your grade 2, 3, 4, 5, 6, and 7 teachers told you that fractions is not going well, you use a calculator to do that. Let's not perform miracles at this stage with online learning. So 3 to the power of n minus 1 is then equal to 242. You add 1 on both sides, so 3 to the power of n is equal to 243. And 243 is 3 to the power of, do you guys know? Sorry, 3 to the power of 5, right? 3 to the power of 4 is 81, times by 3 is 243. So then what do we have? Therefore, n is equal to 5. If you wanted to use logs to do that part, you would say log 3243 is equal to n, and you get the same answer. Okay, so now we know what n is, all right? So n is equal to that. But we need to find m. So let's look at this quickly. So we know that n is equal to m minus 1, right? We now know what n is. N is equal to 5. Okay, so 5 is equal to m minus 1. Therefore, what will m be equal to? M will be equal to 6. Okay, so just remember this last step there. I think it's quite important. Okay, hopefully this makes sense. So you didn't add m in the beginning. The number m, you can work with the number of terms, right? It's the top counter minus bottom counter plus by 1, and you go through the motions. All right.